Assalamu alaikum. Today we have a question on kinematics using polar coordinates. We have a particle P moves along the spiral path defined by r equal 10 over theta feet, where theta is in radians. If it maintains a constant speed of 20 feet per second, determine the magnitudes of the radial velocity Vr and the transverse velocity V theta as functions of theta, and evaluate each when theta equal 1 radian. Okay, now to solve this question, let us start to find Vr and V theta, right? Just like the question requested. Vr in polar coordinates is equal simply to r dot, and V theta is equal to r theta dot. Okay, from here we need to take the time derivative of this. So r dot would be simply the time derivative of 10 over theta. But remember, again, we are taking the time derivative. So here theta will be the derivative of time. So now to do this, r dot would be simply negative 10 over theta squared. But again, since we are taking the time derivative, times theta dot. Okay, I know that some students maybe they forget how to do that. Let me show you what we did here. We have r equal 10 over theta, which is also equal 10 times theta to the power negative 1, right? I just took the theta from the denominator to the numerator, right? And then I'll just take the derivative here, which will be negative 1 times 10 theta, taking 1 from the power negative 2. Now, since we take the time derivative, times theta dot, right? Now, if you look at this result here, it's the same, right? So I just wanted to remind you how to do that. So that's for Vr. Okay, and for r dot, for V theta, we will have r simply r, which is just 10 over theta times theta dot, right? So here we will just plug in the values. We will not do any derivatives here. So we will have 10 over theta for V theta times theta dot, right? So now we have this expression here. The only thing we need to evaluate is this, what is the theta dot, right? Now to find theta dot here, the question says that this particle maintains a constant speed of 20 feet per second. So we know that the magnitude of the speed is 20, and this magnitude is defined as this v equal square root of Vr square plus V theta square. So it's just a normal magnitude of two vectors. Okay. And now I need to solve this for theta dot. So now let me do it here on this side. V, the speed is given to be constant, 20 feet per second. So let me plug in the values here. I will have 20 square equal Vr square would be simply this value here squared. So it will be just 100 theta dot square over theta to the power 4, right? Plus this quantity here, V theta squared, which will be 10 square 100, so times theta dot square over theta square. So plus 100 theta dot square over theta square. Okay, and we need just to solve that for theta dot. So now I have 400 equals, I'll take 100 as a common factor. Also, I'll take theta square as a common factor. Okay, and here we have 1 over theta square plus 1 times theta dot. square. So now from here, you know, I can here, I can make this one fraction. If I multiply here, multiply the denominator here by theta square and theta square here. So you know what, let me do this here in this step. Okay, before we proceed. So make it okay, plus theta square over theta square, right? Theta dot square. Okay, so now we will have this now here is 4. This now has been simplified to be 1. So now theta dot square will be simply 4 theta square over 1 plus theta square over theta square. Okay, just like that. And now here will be just simply 4 theta to the power 4 plus 1 plus theta square. So now from here, theta dot would be simply we take the square root for this fraction. So now he will have, let me do it, write it here. So from here, theta dot would be simply 2 theta square over the square root of 1 plus theta square. Okay, so now we have found theta dot. We can substitute this back into VR and V theta. Okay, so from here, VR simply will be minus 20 times, just times, look at this here. I have theta square here. I have theta square in the numerator here, so this will cancel. So just minus 20 over 1 plus theta square. Okay, so that's my VR. And for V theta, I will have this equals to so 10 times theta dot over theta. Okay, so it will be 20 theta, right? Because here we have theta and here we have theta squared, so we'll have just 20 remains in the numerator. So we'll have 20 theta over 1 plus theta square. Okay, so this answers expressing VR and V theta as function of theta, right? And now we need to evaluate each at theta equal 1 radian. So this is just an angle that we need to evaluate these components of velocity at this angle. So now if we replace theta by 1 radian, you know, remember that the natural unit of theta is just radian, or I mean the SI unit. So now here VR simply will be minus 20 over 1 plus 1 square. So we'll have minus 20 over root 2. Just put this into the calculator. I got this answer, negative 14.14. Okay, just I'll take 3 significant figures, feet per second. Okay, so this is for VR. And for V theta, I'll have also 20 times 1 over the root of 1 plus 1 square. Okay, so we'll get the same answer but positive, because here we are doing this at 1. So I'll get 14.1 as well, feet per second. Okay, so I hope you find this useful, this video useful. Please remember to share and like the video, and let us know in the comments if you have questions or suggestions, or if you want me to solve or explain certain concepts. Please feel free to do so. Wishing you all good luck.